Hey guys, so this lesson we're going to be looking at the derivative to determine where f of x has intervals of increase and decrease. And then we're going to eventually talk about how the second derivative gives us some information about the concavity of f of x. So let's start with this example over here. We have this function 2x cubed minus 3x squared minus 36x plus 4, and we want to find the intervals of increase and decrease. And then from there, we're actually going to be able to identify the maxima, minima, or a maximum, minimum, singular. So how are we going to do this? Well, once we decide where this function is increasing, we know the critical values are where the derivative is 0, and those are going to be turning points possibly. So if I have a critical value and the function changes at the critical value from increasing to decreasing, we can then conclude that that critical value is a max. Okay, that would be a local maximum. And then of course, if we have a critical value and at that critical value the function changes from decreasing to increasing, well at that point then we can say that that is a minimum. All right, so let's get started with this example. First step would be to find the critical values. And so we do that by taking the derivative and setting it equal to 0. So the derivative here would be 6x squared minus 6x minus 36. So we set the derivative equal to 0 to identify our critical values. I can easily factor this quadratic. And solving for x, we get -2 and +3. So these are our critical values. So what we're going to do next is set up intervals with our critical values as the changing points of our interval. So we're going to look at all x values on the domain for this function up here, and the function's domain is all real numbers, so -infinity to +infinity. So the first interval we look at are all the values less than that first critical value of -2. The second interval that we look at is all the numbers between -2 and 3. And the third interval we look at is all x values greater than 3, or values from 3 to infinity. So what we want to decide is, where is f of x increasing? Well, that would be where f prime of x has a positive value. Because remember, the derivative, or f prime, represents the slope of the function. So let's just pick a test point, something that falls in between -infinity and -2. In other words, just some number less than -2. And we're going to evaluate that on f prime. So let's say -3 is our test point. If I evaluate f prime of -3, -3 plus 2, -3 minus 3, we end up with a positive outcome. Okay, so I don't care what that actual output is. All I care about is the fact that it is positive. It's greater than 0, so we get a positive result from testing a number in this interval on the derivative. So we can draw a conclusion from that. The derivative gives us information about the function. That tells us that f of x on the interval for values less than -2, the function is increasing. Okay, so we know that the function is increasing. Okay, let's see what's happening between -2 and +3. So again, pick a test point in here. Let's say we pick 0. We're going to see what happens for the derivative at 0. So for f prime of 0, substitute in 0. Okay, you end up with a negative outcome. So that tells us that the function f would be decreasing on that interval. So notice we have a change at -2 from increasing to decreasing on the function. Okay, this means that we can conclude -2 is a maximum. It's a local maximum here. Okay, let's finish the sign chart here. If we look at a value on this interval, so choose something greater than 3, let's say 4. If we substitute 4 in for the derivative, so plug 4 into here, and we end up with, again, a positive now. So that tells us that our function f is increasing on that interval. Okay, so at 3, we again have this change from decrease to increase, which means we can conclude at 3 we have a minimum, a local minimum. All right, and that's it for this lesson. See you guys next time.